This was the problem. This is the problem. All right. So this is what we did yesterday. We were talking about quadratic functions and putting the quadratic function in the form of that you see in front of you. It's called standard form of a quadratic equation. And we had begun doing this when we would do, when we were doing section 2.3 and we were doing completing the square. And we'll be doing one of those in a few minutes after we do this problem. So the question says, match the quadratic function with the graph. Okay, so in other words, you're given 4 quadratic functions. I like this problem. I've always liked this problem. So you're given 4 quadratic functions, and you're given 4 graphs, and you have to match the graph to the quadratic function. Okay, now the way I would do this is I would first identify the functions that have a negative number, namely the one right up here, number 1, and the one down here, number 4. Why don't I want to focus on those? Because they both have negatives in front. And when you see a negative in front of a quadratic function, it means that it's a quadratic function that has been flipped over, better known in mathematics as a reflection in the x-axis. Okay, so in other words, that's what we're starting with. We're starting with the picture over here for A and for C. Now, the one for A has a vertex of -3, 4, and the one for 4 has a vertex of 0, 1. This one has a vertex of 0, 1. See this right here? It starts from 1. That's this one over here. This one over here indicates that the graph actually starts at 0, 1, when x is 0 and y is 1, as opposed to this one down here, C, which starts, if you count this, 1, 2, 3, -3, 4, and that's this one right here. This one has a vertex of -3, 4, number 1. So C goes with 1 and A goes with 4. Then you have the other two, right? So here they are over here, B and D. Now B has a vertex at 2, 0, when x is 2, y is 0. So the question is, which one, 3 or 4, has a vertex at 2, 0? The answer is choice 3, because here's you always take the opposite of -2, so that's 2, and there's no k here at all, so that's 0. So the vertex is at 2, 0, and this graph has a vertex of 2, 0, when x is 2 and y is 0. Then we come down here and we see that the vertex is 5, -3. There it is right there. 5, the opposite of -5 is +5, -3. So this one, 2, goes with D, and 3 goes with B. It's a very nice summary of 4 quadratic functions and what their graphs look like. This is what we did yesterday. This is exactly a summary of all the quadratic functions and what they look like. These are most of the ones we did. I mean, they're not exactly the ones we did. We did other ones as well, but these really represent a very nice picture of what the quadratic functions look like. Keep in mind that the quadratic function, let's look at number 1, for those of you who weren't here, that it's the x value of the vertex is the opposite of +3, which is -3, and the value of y is 4. So the vertex is -3, 4. The vertex here is 5, -3. The vertex here is 2, 0, and the vertex for the number 4 is 0, 1. So that's what they all look like, okay? And does anybody have a question? So we didn't do much of this type of problem, but this is a nice problem because it sort of summarizes everything we did. And I'm going to get rid of it now. And we're back to normal here. And let's turn the computer and begin going over the homework. So the first homework problem was the one I just did, but the second homework problem, just below it, is page 93, problem 2. And you're given the following function: f of x equals 2x squared. Now, how do you do this? Okay, well, 2x squared plus 12x plus 17 will be equal to y. F of x and y are basically the same thing. So they look, very similar. Now, the way we did this yesterday was the following way. We took the 2x squared plus 12x and kind of moved it over a little bit to the left, took that 17 and brought it over a little bit, moving it out of the way. So we're not going to pay much attention to that 17 right now. However, we have to get rid of this 2. And the way to do that is by factoring the 2 out of this expression. So I factor the 2 out of the expression. 2 into 2 is 1. 2 into 12 is 6. And now we're ready to complete the square. So the next thing we do is to complete the square. Well, how do you complete the square? You take half of 6, which is 3, and then 3 squared is 9. That's completing the square. Close that parentheses. But you can't just add a 9 over here. And actually, I didn't add a 9. I really added a 9 times the number that was factored out. So I really added 18 to this particular expression. In order to offset that, we have to subtract 18. Minus 18. Minus 18. Again, the reason I'm subtracting 18 is because when we completed the square and put a 9 over there, 2 times 9 is like adding 18 to this expression. And to offset that, we had to subtract 18. And that's why I did that negative 18 over there. So what we wind up with is 2 times x plus 3 squared minus 1 equals y. And this is the quadratic function that we're now going to do a number of things to, not least of which is to graph it. So the first thing we want to know is, what is the vertex? This is the original function. We are going to go from this form of the quadratic equation to this form of the quadratic equation by using the method that we learned on Monday, which was completing the square. Remember completing the square? We're going to be using that to get from here to here. This is the form that we're going to use to graph the quadratic function. And what I do is I bring it down here. I move that 17 over to the side. I have this. I factor out a 2. I factor out a 2. I then completed the square by taking half of 6 and getting 3, squaring the 3 and getting 9, and 2 times 9 is 18. Now that 18 that I just added, because it wasn't here before, there was a blank space here, but now I'm putting a 9 over there. That 2 times 9 is 18 has to be offset by subtracting 18. Otherwise, it's not a valid, you can't just go to an algebraic function and add 18 to it. Not 2 times 9 is 18 without also subtracting it. So now it's like we started from scratch. Then you factor this and you get this, but these are the same factors, so you could make it 2 times x plus 3 squared minus 1 equals y. That's where I am right now. I don't know what more I could say. Okay, now we are required to find the vertex. We are required to find the axis of symmetry. This was all explained in the video. I'm afraid to ask how many people who missed yesterday's class looked at the video, because that was the key to today's lesson, that when you miss a class, you watch the video. So I'm just a little out of sorts over that whole thing. Then you want to find the y-intercept. Then you want to find the x-intercepts. These are all the things we need to graph to not actually graph it, but it's called a sketch because it's not really a very accurate graph. Nonetheless, the vertex will be the opposite of positive 3, which is negative 3, and negative 1. This came from the opposite of positive 3 and negative 1. The axis of symmetry is equal to x equals negative 3. The way we find the axis of symmetry is by letting x equal negative 3. That's this. The relationship between this. Let me show you why. Let me show you why. So if the vertex is negative 3, negative 1, this is the vertex, then the axis of symmetry goes through this point, negative 3. This is the axis of symmetry. That's what we found so far. The y-intercept. The y-intercept is the value of y when x is equal to 0. We go back to the original function. We let x equal 0. This term drops out. We let that x equal 0. This term drops out. It turns out that this 17 is the y-intercept. So the y-intercept is y equals 17 when x is 0 and y is 17. So if this is the vertex, then 17 would be way up here. That's where the graph, which is like headed in this direction, is going to intersect the y-axis at 17. But we would like to know where it intersects the x-axis. So therefore, The fourth part of the problem is to find the x-intercepts. So let's do that over here because we need a little more room to do that. Okay, so let's take this right here. This is the graph this is the equation we're looking at. 2 times x plus 3 squared minus 1 equals y. Now, how do you find the x-intercept? By letting y equal 0. So therefore, 2 times x plus 3 squared minus 1 is equal to 0. And now we solve for x, and that should give us both of these x-intercepts. It's obvious that one will be here and one is going to be over here. Okay, so let's now continue working. Positive 1, positive 1. 2 times x plus 3 squared equals 1. Divide by 2. I'm solving this equation. I would suggest changing the 1/2. Remember yesterday I said change the 1/2 to 0.5. Because it will make it easier when you have to use your calculators to find the square root. Now we take the square root of both sides of the equation. X plus 3 is equal to plus or minus the square root of 0.5. And then we bring over the negative 3. And x will be equal to plus or minus the square root of 0.5 minus 3. But there's two values of the square root of 0.5. So x will equal negative 3 plus the square root of 0.5, and x will equal negative 3 minus the square root of 0.5. And now we take our calculators and we find the square root of 0.5. So second function, square root 0.5 and 0.7. Whoops, that can't possibly be right. Oh, wait a minute, maybe it's right. Yeah, it's right. It's not the square root of 5, it's the square root of 0.5, so 0.7. So x will equal negative 3 plus 0.7, and x will equal negative 3 minus 0.7, which means that x equals negative 2.3 and x equals negative 3.7. That's the x-intercepts. Now, how do we use those? Go back to the equation, go back to the graph. Go back to the graph. All right, well, obviously you can't see that, but let me draw another graph. So here's the vertex at negative 3, negative 1, negative 3, negative 1. Here's the axis of symmetry. X equals negative 3. Here's the y-intercept at 17. Right, all the way up there. Now the x-intercepts are negative 2.3. Where is that going to be? Negative 2.3 would be, if this is negative 3 over here, and this is negative 2, then negative 2.3 would be right over here, right over there. And then negative 3.7 is going to be not quite at negative 4, right over here. That would be the other one. So this is what the graph basically looks like. Not an exact location, but this is what it sort of looks like. It goes like this. It goes gradually up like that. It's not a straight line though. It sort of looks like it's a straight line, but it's not. because this 17 should really be much higher, because 17 is high, way up here. So therefore, this is not really a straight line going to it. It's really curved. It curves around like this, and it goes up like that, and eventually it does intersect 17. And this is what the graph looks like. This is one of the x-intercepts at negative 3.70, and this is the other x-intercept at negative 2.30. And this is the complete problem. This is we found the vertex, we found the axis of symmetry, we found the y-intercept, we found the x-intercepts, and we sketched the graph. This is what the graph looks like. And that's exactly what the graph should look like, right there. And that will be on the test. Problem like that will be on the test. That was the homework that I gave you to do last night. Okay? And then we moved on to section 2.5. Okay, so we then moved on to another section. We now move on to section 2.5, and this is what I gave you as an assignment. So the first problem, so this is section 2.5, which was graphing higher degree equations. Graphing higher degree equations or functions, higher degree functions. Let's call them functions. Okay, so this is what the first problem was on page 102, problem B. Okay, here's the function. F of x equals x squared times x minus 4 squared times x minus 3. This is a very, weird looking equation. We've never done an equation like this until yesterday when we did quite a few of them. And the way you graph this is the following way. I made it easy for the class, which you would have seen on the video, by actually saying, okay, the first thing you want to do is list the factors. So the factors are x squared, x minus 4 to the second, x minus 3, and the exponent, just to make sure I have that right, is actually to the first. Those are the factors. The roots, if you know the factors, you know the roots because you set each factor equal to 0. X squared equals 0, therefore x equals 0. X minus 4 equals 0, therefore x equals 4. X minus 3 equals 0. Really? They were both negatives? Okay. X equals 3. Okay. These I get from here. The roots I get from setting each factor equal to 0. Then we introduce something called the multiplicity. All the multiplicity is, in English, is the exponents. But mathematicians like to give things fancy names, so they called it the exponents. They called the exponents the multiplicity. In other words, the multiplicity is simply what the exponents are. Here, it's 2. Here, it's 2. Here, it's 1. Those are the multiplicities. The next thing you want to know is, are these multiplicities odd or even? This is even. This is even. This is odd. So what all this is about is this graph, this very, very complicated function is going to intersect the x-axis when x is equal to 0, when x is equal to 4, and when x is equal to 3. And when it hits the x-axis, if it's an even exponent, then it's either going to go through the x-axis or it's going to bounce. You're going to have to wait to see what that is, those of you who missed it. Well, if it's even, it bounces. If it's even, it bounces. If it's odd, it goes through the x-axis. Okay, and that's really all you need. There's a lot of information, and we're going to be using this to do the very complicated graph that's coming up in a few minutes. But first, we need to know what the degree of the function is, the degree of the function. The degree of the function is the sum of the multiplicities. The sum of the multiplicities. Two plus 2 plus 1. 2 plus 2 plus 1 equals 5. That's an odd number. Therefore, the end behavior of this graph is going to be here and here. In other words, it'll start here and end there. That's what an odd number means. When it's an even number, it means that it starts here and ends there. This is the even degree. If the degree of the polynomial had been an even number, it would have started here and ended there. But it's an odd number, so it begins here and ends there. Okay, now I think we're ready to graph this thing. Da-da-da-da. So here we go. We draw a graph. This is a sketch, it doesn't have to be exact. Now, the roots are going to be 0, 4, 3. Whoops. 3 comes before 4, that's for sure. That we know. Okay, now, so what happens? It starts down there. It's coming up. It's coming up. See how it's coming up here like this? This is where it started. Like I said here, it's going to start down here. It comes to the first point on the x-axis, which is 0. At 0, it's an even exponent, so it's going to bounce. Bouncing means it goes like this, and then it curves around. See, it hits the axis, and boing, it goes the other way. And then it's got to come back because the next value of x is 3, So it's going to come around like this, and it's going to do something at 3. Well, what is it going to do? It's an odd exponent, so it's going to go through. It's going to go through. And then what happens at 4? It's an even number, so it's going to bounce. So it's going to go like this, turn around suddenly, come back to 4, bounce, and go off into space. And that's what the graph will look like. And that's what it is right here. It starts here, ends there. Our graph starts here, ends there. It comes up, it goes to the first value of x, which has an even exponent. Therefore, it does something called bounce. Comes around, goes to 3. What happens at 3? It's an odd number. It goes through. It then curves around to 4. What happens at 4? It's an even exponent. So again, it bounces and goes off into space. Okay? And that's what the graph looks like. And this, again, will be a question on the next test. You will be given something that looks like this, and you will be told to find the factors, the roots, the multiplicity, determine whether it's odd or even, whether it goes through as it did here at 3, or whether it bounces as it did here at 0 and at 4. You'll be asked to find the degree of the function, which was 5. You would be then asked to find the end behavior, which is, from here and here. And that will be the entire problem. So this is a very, very important question. And that's the problem we did yesterday in class during section 2.5. Okay, now I have another one here. I have another homework problem, and that was the homework problem. Let's go to page 104, problem 11. This is a little different. F of x equals x to the 4th minus x to the 3rd minus 3x squared. So this is going to be done the same way we did the problem up here, but the difference is this one has been factored already for us. This one, we have to do the factoring ourselves. See, it's a little weird because we have to actually do the factoring ourselves. Well, how do you factor this? Well, it's got, a factor of x squared times x squared minus x minus 3, and that will be equal to y. Well, this is weird because it doesn't have, you can't factor this. What did I do wrong? Oh, it's not 3x squared. Why didn't somebody stop me? It's 30. That makes a big difference, ladies and gentlemen. 30x squared, and therefore this number is 30. Okay, now it makes a lot more sense. Okay, so I read that incorrectly. This was the original problem. When we factored out an x squared, we were left with x squared minus x minus 30. So this is x squared. This can be factored into x minus 6, x plus 5, and that equals y. So actually, this is a little more work. We do our chart. The chart, that's the power of the chart. Allows us to put our thoughts in order. The factors, the roots, the multiplicity, Well, let's start it off. The factors are x squared, x minus 6, and x plus 5. The roots, when x squared equals 0, x equals 0. When x minus 6 equals 0, x equals 6. When x plus 5 equals 0, x equals negative 5. The multiplicity, 2, 1, and 1. Odd or even? Even. Odd. Odd. What happens when it's even? Does it bounce or go through? It bounces when it's even. It goes through when it's odd. It goes through when it's odd. That's all we need to know. That's all we need to know. Now we need to know the end behavior and the degree of the polynomial. So the next step is to find the degree of the polynomial. Remember, the degree of the polynomial will simply be the sum of the multiplicities. 2 plus 1 plus 1, better known as the sum of the exponents. 2 plus 1 is 3, plus 1 is 4. So the degree is 4, and therefore the end behavior will be here and here. Because 4 is an even number, and even numbers have an end behavior looking like this. And that's all we need. So we know that the graph is going to start here and end there. I like to start on the left and work, to the right, the way you read a book. So let's see what happens here. Take a graph, and the place where this equation, this function, will intersect the x-axis will be at 0, at 6, which is out here, and at -5, which is out here. These are the three places where the function, the graph of the function, will intersect the x-axis at those 3 points. And it's going to come down here, right? Coming down, very nice, not bothering anybody. And it gets to -5. And what happens? It goes through. Goes right through. It sees the -5. It just continues going down. But it's got to come back because the next place on the x-axis is the 0. So it goes down and curves around. And when it gets to 0, what happens to it? It bounces. So when it gets to 0, it comes around and bounces. And then it's got to turn around, though, and go this way, because it's got to now go through x equals 6. Well, what happens at 6? It goes through. Therefore, there it is. That's what the graph looks like. Actually, not really, but that's as close as we could get to what the graph actually looks like. And you can see how the end behavior really helps us, because we know the beginning and the end. So we knew kind of when it was down here that it had to go through. because in order to get to the end point, it had to make this turn and wind up over there. Now, the reason I said that's not really what it looks like, I think very seriously that it goes way, way down. It doesn't go over here and turn around. I think it's way down here and turns around. I think this one is way down there and turns around. And the way to determine that, we're not going to be doing too much of. But somewhere along the line, you may have a professor who says, I want to know how far down this curve is. You know, it's going to turn around, but where does it turn around? There, does, you know, even further down. So I'll tell you how to do that. So let's take this one, for example. So from 0 to 6, pick a number in the middle. Let's say 3. 3 squared is 9. 3 minus 6 is -3. 3 plus 5 is 8. So 9 times 8 is 72, times -3 is -216. So indeed, it does go way, way down there. In fact, it goes to a point that we can't even graph because it goes so far down. See, so that's where it goes. And this one, I have a feeling, is the same thing. It's going to go way, way down. But for our purposes and for the purposes of taking an exam, it's sufficient for you to simply show that it curves around and winds up going back up in that direction. These are 2 examples. This one you had a factor. The one you're going to have to come to grips with for the test and the final will be the one on top here. But this is what it looks like. Below, once you factor and you get this function, this is what you're going to be using. So, you know, this is not going to be part of the exams, but this one, you know, up at this point, it will be. And the difference is that we have to factor this. The one on top is just given to you already factored. And those are the problems that you will need to be able to do. And if you want to see more problems solved of this type that we just did, starting at the top and going all the way down to the bottom, we did 2 problems here. We did more problems yesterday as part of section 2.5.